This video covers hypothesis test for the difference of means, and so when you conduct a hypothesis test, there are 5 steps you always follow. You need to state your hypotheses, and in these problems, it's always going to be mu1 minus mu2 equals 0 for your null hypothesis, and then your alternative hypothesis is either going to have a not equal to, a less than, or a greater than statement. These hypotheses are actually the same as stating that mu1 is equal to mu2, mu1 is not equal to mu2, or mu1 is less than or greater than mu2. And so you can use either of these hypotheses. Then you need to check your assumptions for the problem, and you're either going to calculate a z-star or a t-star for your test statistic as well as your p-value, and you should already know how to interpret these. If your p-value is less than or equal to alpha, then you reject your null hypothesis. If your p-value is greater than alpha, we fail to reject our null hypothesis. And then when we interpret this problem, we state that there is either sufficient or insufficient evidence that the alternative hypothesis is true. And don't forget, when we reject our null hypothesis, we have sufficient evidence, and when we fail to reject our null hypothesis, we have insufficient evidence. Now let's look at an example. Of interest is to conduct a test to determine if the mean GPA of all student athletes is higher than the mean GPA of all other students at the same universities. There are 2 populations, all student athletes and all other students who are not athletes. The parameter of interest is mu1 minus mu2, the difference between the mean GPA of all student athletes and the mean GPA of all other students. The goal is to test the hypotheses at significance level alpha equals 0.10. Suppose that for all student athletes, the standard deviation of their GPAs is 0.74. And for all other students, suppose the standard deviation of their GPAs is 0.82. A simple random sample of 34 student athletes is selected and their GPAs are recorded. The mean GPA of the student athletes from the sample is 3.07. An independent simple random sample of 102 other students is selected with a mean of 2.96. So if we want to test our hypotheses, first we need to state the hypotheses. And in this problem, you're always going to use mu1 is equal to mu2 or mu1 minus mu2 is equal to 0 for our null hypothesis. And in this problem, it says if the mean GPA of all student athletes is higher than the mean GPA of all other students, then this is a greater than problem. So notice that mu1 has to be all student athletes because it's greater than mu2, which are all other students. So make sure you define your populations before you move forward. And once you've defined your populations, we can then check our assumptions. So in the problem, it states that we have a simple random sample of 34 student athletes, and then we have an independent simple random sample of 102 other students. So we definitely have 2 independent simple random samples. And then for our central limit theorem, there are no statements about the distributions, and so we just need to make sure both of our sample sizes are greater than 15. We have a sample of 34 and 102, so both of our assumptions are satisfied. So now if we want to pull information from the problem, all of the student athletes have a standard deviation of their GPAs is 0.74, which is a population standard deviation. And then we're given a sample size of 34, and we're given a sample mean of 3.07. And so that's the information involving our first population. As for our second population of all other students, the population standard deviation is 0.82, and we have a sample size of 102, and it gives us a sample mean of 2.96. So once we have this information, we are actually going to use the calculator to calculate our p-value. And so if you go to stat test and 2 samples z-test, if you enter your information, you'll get a z-score of 0.7301 and a p-value of 0.2327. So we can use our p-value and compare it to our significance level of alpha equals 0.10. Notice that our p-value is greater than alpha, so we fail to reject the null hypothesis. And this leads to an interpretation that therefore we have insufficient evidence that the mean GPA of student athletes is higher than the mean GPA of all other students at the same university. So if we look at another example, let's say now we have the same information, but now we are given sample standard deviations instead of population standard deviations. So again, we are testing if the mean GPA of all student athletes is higher than the mean GPA of all other students at the same university. And so again, we have mu1, which is our student athletes, and mu2 is going to be the mean GPA of all other students. And so once we set up our hypotheses, we need to check our assumptions. Again, we have two independent simple random samples and nothing changed from the previous problem. So our central limit theorem, again, we're going to check both sample sizes compared to 15, and both of our assumptions are satisfied. So now when we move forward, if we look at the GPAs of student athletes, we have a sample size of 34, but now we're given a mean and standard deviation for the sample. And so we have a sample mean of 3.07 and a sample standard deviation of 1.5. Similarly, for our other students, we have a sample size of 102, a sample mean of 2.96, and a sample standard deviation of 1.2. Using this information, if you have sample standard deviations, not population standard deviations, then you will use the calculator for a two-sample t-test, and you should calculate a t-score and a p-value, which you need to report. And then again, you can use your p-value and compare it to the significance level. Here, the p-value is still greater than alpha, so we fail to reject, and we come to the same conclusion that we have insufficient evidence for our statement. And so in the next two videos, we're going to go through both of these examples using the graphing calculator.